The other one I want to look at is number 3. And so what we have to do here is take these word descriptions of sets in different settings. This one is in the real numbers, this is in R2, this is also in R2, this is the real numbers as well. So what we have to do is try to describe those using intervals. Okay, so the third quadrant, just to remind you, this is the first quadrant, the second quadrant, and the third quadrant, and the fourth quadrant. So this is the one we're interested in here. And so what we want to do is try to describe it in terms of intervals. So this is what I'm interested in there. And the way I can describe that is, here's an interval here, going in this direction, and an interval here in this direction. And so if this is my x interval, and this is my y interval, then the box that they make is the third quadrant. So the terminology that I want to use in terms of these intervals is here I'll go from negative infinity to 0. And then I'll cross that with the y, which is 0, also negative infinity to 0. So that's the third quadrant. Okay, this one here, absolute value, this is one that you learn about when you're younger, but sometimes you have to be reminded how to deal with absolute value. So the way it works is, remember that absolute value, it has two potential answers. And when there's an x inside the absolute value, ahead of time, you don't know whether the stuff inside the absolute value is positive or negative. So there's two possibilities depending on what x is. For instance, if I put in 0 here, I know that the absolute value is going to turn that negative 3 into a positive 3. So that's a case where the absolute value modifies what's on the inside. If x were equal to 4, for instance, then 4 minus 3 is 1, and the absolute value would do nothing. So there are two situations, one where it does nothing, and one where it changes things from negative to positive. So how do we depict that? There's this possibility, negative x minus 3 is less than 4. That's the situation where it's going to modify what's on the inside. It modifies it by multiplying it by a negative 1. And then the other case is when it doesn't modify it at all. So those are our two possibilities, and then I just solve for x. So over here it's quick, x is less than 7. And then over here I get negative x plus 3 is less than 4, negative x is less than 1. And then of course a good opportunity to remind you of how you deal with the inequality. When I multiply by negative 1, I have to flip the inequality. So x is greater than negative 1. If you have trouble remembering that, then all you have to do is just bring the x over to this side, add x to each side, so that puts an x on the greater side, and put the 1 over there, and you get the same thing. Okay, so x is greater than negative 1 and x is less than 7. We can depict that on the number line here. There's 0, here's negative 1. There's 7. So what we're talking about here is not including this point, not including x equals 7, but everything in between. Okay, so that's what this is depicting. In terms of an interval, that would be the interval negative 1, 7. So then we can write that in the interval notation. Okay, for x squared is greater than 4, let's just start to solve this. So this would indicate that x squared minus 4 is greater than 0, which is x plus 2, x minus 2 is greater than 0. So let's look on the number line at what happens here. Here's 0. Okay, it's equal to 0 when x is 2. And it's equal to 0 when x is negative 2. So when is it greater than 0? So these values are not allowed, because that'll be equal to 0. How about on the inside? So how do I make this positive? They're either both positive, and that would mean that x plus 2 is greater than 0, and x minus 2 is greater than 0, simultaneously. So that would mean that x is greater than negative 2, and x is greater than 2. Okay? So how can we get both of these to happen at the same time? X is greater than negative 2, that's all of this stuff. And x greater than, and here's 2, here's 0, and here's 2. And x greater than 2 is all this stuff. So where they overlap, it's just here. So for this we get x greater than 2. Okay, so that's both positive, and then both negative. That means if this is negative and that's negative, if I multiply them together, I'll get a positive result. So that means I have x plus 2 is less than 0, and x minus 2 is less than 0. So here we have x is less than negative 2, and x is less than 2. So how do we get both of those at the same time? This is that one, and x less than 2 is all of this stuff. So where do they overlap? Right here. So that is x less than negative 2. And we can depict that in an interval here as 2 positive infinity, and here it's negative infinity.